All right, so let's go over to the assignments. We're going to take a look at assignment 4. And notice that you have a DWG file. All right, so we're kind of transitioning out of you have to draw to you can draw if you want to. One of the things with this shape is we have the center and then this outside circle. I also think that at least 1 or 2 versions previous I went through the drawing on this, so or the actual sketching it inside of Mastercam. Uh-oh. Come back. There we go. Okay, video problem. So most of what we're going to do in industry, though, is somebody's already drawn this. They've sent us a DWG. As we progress, we're also going to be able to use wireframes, solids, not so much surfaces. Way back in the olden days when I started programming, it was pretty much wireframe and surfaces. You had to create the surfaces to make your complex geometry if you wanted to do any kind of 3-axis. Now the solids are coming in with all of those shapes, so we don't tend not to do anything with the surfaces at least as much. So if this comes in as a solid or we do anything additional with it, we're going to be able to pick on that geometry itself. So aside from importing it, the last 2 exercises are one for mill and one for lathe, is drawing with the solid geometry inside of Mastercam. And then the one that I will I'll kind of maybe put it up in the discussion or survey type deal of if you're interested in seeing Mastercam solids running inside of SolidWorks, since there's a handful of people that are crossing over with the SolidWorks class. I won't make it an assignment, but I'll be glad to demo it and have a discussion over what's involved in any program that lives inside of SolidWorks. Okay, so looking at this shape, we have the little pocket. We're 5/8 on the thickness. We have the the outside shape. But because I have this DWG, I've already downloaded this, so I don't need to do it again. But if you click on that, it should put it in your downloads folder. You can move it over to your project folder, whatever you need. And then once we go into Mastercam, we're actually going to have it open up that file. So I can go to File and Open, and it's going to give us the list. Let's see, maybe I should go the other route, go up. That's the one I was looking for. So I think the other one has the files of types. I can get to it easier here. So up on the little ribbon, above the ribbon, the little folder with the open, that gives me this interface. I like it a little better. And we need to make sure that under the Mastercam files that we are telling it that it is a DWG. And if you go to all files, then it's going to show you everything in that folder. So we can kind of filter it out. And when we're doing a Parasolid or a step file or any of the other types of solids in the next couple of exercises, we'll switch over and filter for those. All right, so I tell it that it's an AutoCAD file. I need to get to my downloads since I didn't move it. And then there's the file that was on Canvas, and I go ahead and click Open. All right, so it comes in with geometry. So what I don't have here, or it didn't come across, is I'm not exactly sure what the scale is, but in this environment, one of the first things we need to check for is it scaled properly? Is it too big? Is it too small? Is it just right? All right, until we know that, we don't really need to do anything else. All right, so I have a radius of 0.625 on the outside. We have 1 inch on the thickness and a diameter of 750 on the circle. So if I highlight that and I hit F4, or we right click and go to the analyze properties, notice that my radius is 0.1875 and my diameter is 0.375. So I'm at half scale. So I wouldn't want to program this and then realize, oh, all of the tools I've just selected are probably too small. I could have gone with bigger tools and taken bigger chunks out of it. So we're going to close that out, and I'm going to take the entire title block, and we can click and click, And over in the transform, very end on the size, we're going to be able to scale. I'm going to move it around, so uniform or bi-axis. And at the very bottom, we are scaling to twice. So 2 times. And no, I didn't want to copy it. I want to move it. And we will accept. And now when I come back to that circle and click and hit F4, I can see that it's at 0.75 with a radius of 0.375. That's my confirmation. All right, so for this, everything was selected. So if I do a move to origin, and the point to translate from will be the corner. And then on our print, it showed it, what, a 1/16th? So we're 2 1/4 and then 2 1/2, so 1/8 of an inch in. And, well, let's just call it 1/8 of an inch, 1/8 of an inch. All right, so if I go to transform that by moving it one more time, and we go ahead and, let's see, we need the last. I say should have picked everything, but we'll go ahead and make sure I get it. And then in selection. All right, we're going to move. And the deltas are going to be 0.125. And then in Y, minus 0.125. So I'm getting everything in position. And pretty much when I ran through this, checking out the DWG earlier, I managed to not scale the title block, and then when I moved parts, all the dimensions moved away, and it looked really weird. So if we think about it in those terms, let's do all of our manipulations before, and then I wouldn't have to do those undos to get it back to this point. But I'm happy with the results here. And it's one of those, you're not going to think about it. Do I really need all of the title block and geometry? Not particularly. I could just go ahead and erase it. If it's handy to have it in the background, we go ahead and leave it. All right, so on the levels then, this came in with the 2 levels from the drawing. If this came in from AutoCAD, it may have 5, it may have 10 different, in AutoCAD, their layers. It may have a variety of different geometries that show up in that in those groups. All right, so I want to add one more layer, and I'll just make that a title block or a title. And that is now the current layer. So we're going to set all of the entities. And I want to go up here to the selection method and selection mode. If we go to mode, I can pick everything outside. So I don't have to window pick and do individual items. I can say everything outside of my geometry. So if I get pretty close here, and I should have made it a crossing because I don't think it got that one. Oh, it did all right. And then in selection, I'm going to move that over to level 10. And then hit OK. Now if I go back and make level 1 the current checked item level, I can hide level 10, and pretty much everything except for my geometry goes away. 2 center lines. All right, I'll deal with those. We go click, click, and we'll do another set all. Go ahead and make sure that it's going to 10, and if they disappear, it went to the layer. Sorry, level. And then we'll make one more. Well, I should be able to rename that one on the fly. Let's make that 4 since it's part of the group. Maybe not. It'll just update. All right, so since I'm going up in levels, okay, we got 1 extra. Item 20 then will be the stock. I may not want to see the stock all over the place, but we can go back into our wireframe now, pick up the rectangle, and I brought those back. How did I do that? title, and I'll use 4 later if I need it. All right, so rectangle. Got to make sure to get back over to. It jumped. I was still looking at the levels. All right, so the width is going to be 6 inches, and the height was 2.5. And if I want to draw it into quadrant 4, I need to make that negative so that I can come up and pick on the origin. Preview looks pretty good, so we can use that geometry and then go ahead and accept. All right, so I have another one. If the stock isn't helping me, then we'll make one current. It's something else that I can go in, turn on, turn off, and use as needed. Okay, so that's all the prep from a drawing. The easier would have been just to say delete everything outside of this box, the title blocks, the dimensions, everything goes away. But on the off chance that I want to go back and check it, or I want to reference to this document, I can still pull that up and have that information available by, let's just check a dim real quick, and that is 0.75. So I ought to be able to get a 1/2 inch end mill in there, okay, and not be in any kind of collision. And then when I'm through, okay, we're done. All right, so let's go ahead and clear colors so I get back to something I can recognize and is visible. All right, in the lower left on the tabs, I'm going to go back to the toolpaths, and now we're ready to pick up our machine geometry. All right, so we're going to pick up the mill and the default. Same basic process that we're going through as the files. And I've been looking for more of the defaults for the tool settings, because anything I'm changing over and over and over again, I really want to know where in the settings or where I can place these. So most of these are going to be able to, we'll go back into the configuration and be able to set default tool libraries, for instance. When we come over to the tool settings, well, my default program is 1 or 10 or whatever we want to call it, and depends on the workflow and the style and how you manage the control. Older controls had the whole 1 megabyte of memory, and so if we filled it up with a 3-axis program, wasn't too far away from having to hook up the cable and go DNC, direct numerical control, to run anything above a meg. All right, so being able to have multiple programs, go back and run them, but for the most part, I want to say my strategy, since I am traditionally low production, we load up a program. I don't see it again for a couple months. I go find that program, look at it in the software, do a preview, get my head on straight as to what I'm expecting this thing to do, and then I post fresh code. If I want to make any changes, or I remember something from last time that I wanted to make a little bit better, I go ahead and do my analysis. I'm happy with it. Then I post fresh code, take it over to the control. I'm running the part number. So I would like to have this default to assign, warn, and we haven't gotten further into the tool library. So that will be let's say another add-on video at some point when we want to go a little further into the tool library and have it drive the settings. All right, and then I'm not a big fan of the sequence numbers, so I did see where to turn those off. And if we stay with the aluminum, mill current, let's go to mill library, and we'll set it to 6061 and accept. And then we get to the stock. So one of the reasons I'm drawing the stock, if it's available, is that it's a lot easier, or having a lot less trouble doing select colors, the corners. When we get to the solids and we actually have depths and additional geometry, then we'll look at the bounding boxes. We'll look at the solids. We'll look at entities, what those other filters do for us in speeding up that process. So if I go to select corners, then I'm picking to the edges of my stock, and the only thing I really have to set is depth. And so when we bring in a wireframe, I would rotate over, and instead of going from corner in the top plane to corner in the top plane, I would rotate over a little bit. Now after I'm out of the command, pick the top corner and then find something on the lower right corner that demonstrates that volume so that it also calculates the depth. All right, so our stock was said to be 0.625, and that's always going to be positive numbers. Again, if we need to shift, we're coming over to the stock origin. I do want to display the stock, and if you've tried the solid and you like the solid, keep using it. If solid's really not my thing. I manage it better in the wireframe. All right, and then everything else is looking pretty good. We'll get to those. All right, and then a rotate over just kind of verifies the volume. All right, and so our fairly simple prismatic shapes are not that complicated that I really need to project anything down to the next level or to set up a depth. It's not really helping me at this point. I can get those values off of the print or off of the other level if we need it. Okay, so we're ready to start our program. And one of the things I want to point out is I've been in the help file for the dynamic a couple of times, and it has some information. So the blend, the dynamic milling tool pass, that's kind of the top level. Either that or the high-speed mill tool pass. We'll pick one. So they use the standard terminology, using more of the flute, so you're not wearing just like the last quarter inch. And it's pretty apparent when you have something like a titanium nitride or the zirconium nitride coating, and you do a lot of pocketing at a quarter inch depth and then feed down the next level quarter inch depth, that you're putting that wear. It may only be tenths of a thousandth or over time, relate to a thousandth, but the rest of the flute really wasn't in use. All right, so the whole thing with the dynamic milling, the strategy is to get more of that flute length engaged, reduce the harmonic of an extended tool, and they use the terms of where did it go? The better chip evacuation, tool burial avoidance. So one of the things with any standard pocket is your first pass through the center of any pocket is typically full width, full depth. It is a much higher loaded operation, a much higher spindle load, looking at it from the machine standpoint. So if we can get this engaged and nibble away and not ever see that spike in spindle load, that is going to increase tool life. All right, heat buildup, the whole purpose is to have the chip carry the heat away from the tool and away from the part. If you're done with the part and you pick it up and the part's warm, the heat's going the wrong way. It should be in the tool or going away with the coolant. I think I mentioned one of the machines I run has the coolant tank in the casting, and every time I filled it up, it's made it barely a month, and it smells like you don't want to know. And so I've gone over to the cold air gun or machining dry, and as long as I adjust, I'm not losing much time for the rigidity of the machine, but I'm not having to do all the cleanup and deal with the nasty. So one of the things I'm really concerned with is evacuating that chip and having it carry as much of the heat as possible. All right, so these are the kind of terms that they come up with. And then we go into the blend. So it gives us a quick overview and pretty much none of the settings, none of the selections that would really be useful. But it does give us a couple of hints, more smoothly between two open chains. So that gives us a hint of what we're going to select. And the peel does the same thing, going between two pieces of geometry. Kind of not a lot of detail in the selection, but a little bit more, because my natural tendency would be just to start clicking and say, do what I want. And then it says, can't do it with that geometry. Let's see, where did the other ones go? To the tool pass, the area mill. And so rest milling strategy from outside strategy, stay inside. I think this is really what I wanted to do last week instead of the contour. So we'll take a look at those two options. And then let's see, there was it was a high speed. contour. And not seeing it. Contour walls. All right, well, we'll come back to it. Anyway, the help file isn't much help, but it does glean those one or two little clues that are going to be able to move this along. All right, so I've tried the open strategy. So let's go over to a 2D high speed. And so we had dynamic mill and dynamic contour. All right, so I think I want to try the area mill first. And since it said to, machining regions. And we'll see if it takes the full path. Stay inside or from outside. And I think from outside is going to stay outside of the part there. So let's just do a stay inside to begin with. We'll go ahead and accept it. Pick up our tool. And again, on the library tool, it's still defaulting back to the standard. So I'm going up to my documents and master. If you have not set up the library using the class computers where the library doesn't get retained, just go ahead and pick a 1/2 inch end mill. I want to kind of get you into the mode or thinking that in your corporate industrial life, you want to have all of your tools available. All right, as you get into the libraries, we can set this as the default library. I want to kind of go through this process enough that you're picking. And really, this whole tool crib tool library comes back to, as more machines have side mounts or tractor tool holders, the umbrella doesn't really lend itself to having tools reside in the machine. But if I set up for an aluminum run and I have 4 different part numbers, but I know that they're going to use the same grouping of tools, then I want this list that I can go back to, and I would just set it as the default. I'm going to program for those groups and just keep using the same list. So one of the things we need to do is get out in front of the machines and look at the different touch-off strategies that make that happen. All right, so I'm going to pick the number 1 1/2 inch, and we'll go ahead and hit OK. Comes in. So this is where, if I had saved in that tool library the feeds and speeds that I'm most commonly going to use, I would just glance down here and go, it's good, next. I wouldn't have to kind of go back to those numbers. So we said we're still staying with the TM, which is 4,000 RPM max, and the 12 inches per minute is probably aggressive for a standard operation. But if we get into the dynamic, I would probably be bumping that up into the mid-20s, almost doubling it as far as the feed rate, if I can get it to get engaged and make the cuts. All right, so had not noticed that one, so that must be new for 2020. We only looked at it the last 3 weeks. So tool inspection changed, so apparently it's going to force the macro that goes and sends it over to the Renishaw probe and say, yep, there's a tool there. It's still on diameter, still on length. We have tips. Inspect it before you put it away, or inspect it before you use it. Not concerned with the holder. Again, the stock is kind of assuming that we've run previous geometry and we're looking for that rest machining. So compute remaining stock for the rest material, or make adjustments as needed. So if I use the largest tool possible in this area clearance, knock out as much material, and there's a little corner someplace that it couldn't get into, then we could switch over to the 1/4 inch tool and say, okay, go find that rest material and do an area clearance on it as well. Our cut parameters, we're going to stay in climb. There are times where I will do, we'll go with the conventional. I want to say one of them I think has a both, which is interesting. But when it goes back in if I do a side-to-side climb and then conventional, usually I'll either slow the conventional down a little bit because it's not ejecting the chip as efficiently as the climb. Percentage of diameter, let's go with maybe 10%, which should be a minimum value. They go to 0.27 and a max of 0.50. For a half-inch tool, that seems like a little bit. Consider that we're going to go a half-inch deep when we're going around this part. So as we increase the depth, we take a smaller radial cut, and we're able to increase the feed rate. So right now, first pass, I still want that feed rate kind of low because I don't want to scare myself on the first engagement. If it's machining reasonable, I can get a little more RPM out of it, I can get a little more feed rate out of it, then I can make those decisions and come back on the second or third generation of the program and make it that much more efficient. So maybe 5 thousandths on the wall. We're going to machine off the bottom side as sacrificial material, so not too worried about stock to leave on floors. So we'll set that to 0. The depth cuts, we're going to go the full half inch plus a little bit. Trochoidal motion, if I set it to minimize the burial. Step over adjustment, 10% of max step over. Initial loops, retry loops, minimum loop radius. A lot of those we're going to have to see what they do. If there's something that is an issue, we come back, we change a few numbers, see if it gives us a desired result. For the most part, stay with the defaults and then see what it does. Transition, still, if I have my choice, I'm going to go with the profile ramp, just because there are times where that helical entry can be a long, painful process. If I'm just ramping back and forth, that linear move may still be a long process, but somehow it doesn't generate as much code, so it's maybe not as painful to watch. All right, so Z clearance, where is it going to start at? Above the part. Usually I'm going to bring that down pretty close. I have to trust my touch off if I bring it down to like 30 thousandths. That's still going to, in the linking parameters, I can still set my clearance plane up 100 thousandths, 200 thousandths, whatever is my comfort zone. But as it does that pause through the retract, I'm probably reversing them again, but through the retract and then into the clearance, then it goes right to that 30 thousandths above, and it starts its ramp to get engaged into the part. Plunge angle of 2 degrees. Again, we'll have to see what it looks like. Preferred profile length, 1/2 inch, and skip pockets smaller than. The tool won't fit in. Yeah, we probably have a little bit of an issue there. And then if we want to go to breakthrough amount, again, if you use the breakthrough amount, do it consistently. And then in your linking parameters, if you're going to set the depth plus 10 thousandths, plus 30 thousandths or whatever, pick one and stay consistent with it. So if I say I want to go another 10 thousandths, whatever I put into the linking parameters, it's going to add. Or my other option is to say I'm going 1/2 inch deep, I need to give it a minus 5/10. So I don't care which one you do, just do it consistently. So you recognize that if there's something wrong with it, you know exactly where to go and look. It's not guessing which way to pick it. All right, so top of stock is 0, feed plane 100 thousandths, retracted 1/4 inch, a little close, but we'll get past that. And then the depth is minus 0.5. And we're still staying in absolutes because I really don't have that wireframe geometry or that usable geometry that we're going to get when we go over to into the solids. The high-speed tool leads. Vertical arc entry, that can be a little weird, intimidating, watching it kind of make that swoop in and swoop out. But it does work, and kind of it's hard to see maybe on the preview, but that is starting at a vertical and swooping in, not coming in off the side like a normal lead in. Yes?
Is it tied to your stock?
That I don't know. I haven't used this lead that much. Usually you are giving the clearance, and since we're not picking up the lead in, I'm going to say, yeah, it's going to be outside of the stock. So
I come from the Gibbs can,
yeah,
and that it's tied to that stock where that's an important
Right.
If you don't have it, it could be some crashes going on.
Yeah, and the little too exciting is getting into it. Now the other part of it is some of these are depending on the operation, they're micro retracts. So if it can move around in the bottom of the pocket or on that ledge, instead of coming all the way out of the part to the clearance plane, it'll come up 10 thousandths or 20 thousandths, whatever we tell it. And when it comes back in, instead of plunging straight down, it uses that arc lead to kind of gently get back into the material and make the cut. Well, let's see what we get. All right, so apparently I picked everything, and oh, that's right, we were on the inside. So what I was looking for was kind of I got off track there. Actually, on the linking parameters, I wanted to keep this at 0. And there's one of the uses that I do for the area mill is let's go up to about 70% and nothing to leave on the walls. And we'll regenerate the dirty operation. All right, so on the top, instead of loading and unloading as we go through a normal pocket, if I'm going to try to get this piece a little bit flatter, then instead of transitioning by 90-degree turns, this will come over, make these extra loops, make the little jog lead-ins. Probably don't need that much of a loop, so that would be something I'd go back and adjust. But this is going to be able to have that lead in without coming to a stop, changing direction, coming to a stop, and going. The tool's always going to be in motion, so it gives a little smoother, a little bit better transition as we try to get away from maybe a face mill or loading another tool. All right, so just something to think about. Let's go with that one again, and I will change the geometry. So I'm just going to copy it over, paste it. And one of the things we haven't done too much, there's another way to get into the geometry. So if I double click, that pulls me into the chain options. And this time I'm going to go from outside. And when I clear the manager, we're going to delete that one, right click and add another one. Let's start the chain over here. It finds its way all the way around. And we go ahead and accept. And then accept. I really didn't do anything except now I am outside of the geometry with a dirty operation. So when I go into the parameters, I know that I reset that depth. We'll go to minus 0.5, accept it, and adjust it. So still have the heavy duty offset. So let's go back to the cut parameters. I'll bring that back down to 10%. And we'll regenerate one more time. And let's hide turn off the display for the first one. And that went inside, didn't it? All right, so one more look. Machine strategy from outside, shortest distance. And there's the direction. All right, so my arrow's to the interior. And if we can change the side, put it to the exterior. Then when it makes its approach from the outside, I'm hoping this gives me the cut. No, still found its way in. And then the cuts are coming in on that little ramp. All right, so one more. Let's go with the machine regions. I'm going to delete that one back out, add it back in as the stock, and that one's going to be from the outside. And then we have these other avoidance and containment. So let's see if we can tell it to avoid all of that interior geometry. And we'll look for a combination that keeps it to the outside. All right, so some extra moves. But if I'm getting that engagement and we get it open up and I can take those cuts, then I can speed up this process quite a bit. All right, so again, the help file is not giving us step-by-step on those parameters. So I'm looking for a result. I'm making a small change, usually one change at a time. If I go in and I just really start clicking buttons, I'll get myself in a lot of trouble. And we're just trying to pick some of the operations out of it. All right, so let's hide the display on that one. We'll go over to Mill Toolpaths, back into the 2D high speed. So that was our dynamic mill. Contour, I think the dynamic contour would be more along the lines of that rest machining for what we did on the Star. So I'm going to kind of jump over that one here. We want you to take a look at the area mill. And so if I do the machine regions, let's just see what it does between two pieces of geometry. So I'm going to go to a partial, and we pick up one, and we have the end chain, and then under the selection I can end the chain, and no, I don't want a third. All right, we're going to stay inside, and I think that will give me a result. So the toolpath type is, notice we can switch between the area mill, the dynamic mill, the contour, the peel, and the blend. Inside of the operation, if I find that, well, that really didn't work based on the geometry, I can try one of these other items and switch pretty seamlessly. Still with the half-inch end mill. We've already removed most of the cuts, so let's see. Let's leave the trochoidal off and see what that does. We'll come back and revisit it. The profile ramp, I think I was reasonably happy with that. And it's picking up, oh, I'm doing another area mill, so I thought I was in dynamic. All right, let's see if we can switch to dynamic. Toolpath type, we'll go over to dynamic mill, and it's still looking at those interior. Climb, tip, first pass offsets, speed reductions, step over amounts, minimum toolpath radiuses, gap size. We have a lot of parameters in here that we can really go fine tune this geometry. Entry motion, plunge only, custom, use entity chain, helix, followed by full medial burial, by trochoidal burial, by profile. I think we'll stay with the helix to be safe on that one. Helix radius, let's give it 100 thousandths or so. That'll spin around the little overlap on the center. And a plunge angle, the 2 to 3 degrees was working pretty well. 10 thousandths linking parameter, depth of minus 0.5. And let's go ahead and see what that generates. All right. So it found the one, and then it found everything else. All right, so my two chains did not do as expected. So let's go back and see what it looks like on a peel type. And we'll just kind of go back through dynamic peel. Cutting method will stay in climb. Approach distance, let's give it a little bit more, at least the radius of the tool. Step over amounts at 10%, still look okay. No stock to leaves, and minus 5. All right, so go ahead and regenerate. All right. So between the two, based on the geometry they picked, that dynamic peel comes up to the arc. And on the previous attempt at this, what I found is if we split this at the arc, is it would bring it all the way up into that arc. And the peel would look at it as two separate pieces of geometry that it would have to come up and then pick from the other side as well. And then the last one, let's see if we can just change it out of the cut parameters. We got the dynamic peel and the peel. I wanted to see about the blend. Same thing, if I'm going to change these, I'm going to look at every one of these tabs, go through the process, and zigzag method. So this is the alternating climb and conventional. First pass feed reduction, if it's fully engaged, we can slow it down. And then max step over, still at the 50%. Extending entities and entry and extending the exit. We'll see what we get. If we want to make the finish passes, again, if we need more control over it, we'll set it as a separate contour. If it's something that is going to be pretty straightforward, we'll let it come back and do the finish passes within this operation.
Did you use dynamic for finishing or just for left?
No, the finish pass is still going to go back to a standard, yeah, but you're not going to have the same level of control that you will creating a separate contour. If you can get away with it and it's not critical, you have a nice, plus or minus 5 tolerance that, we're probably going to be able to hit. And if we're making, a couple dozen parts that we can dial it in and bring it closer and closer to tolerance, then probably not going to worry about it. If it's something that is a bore, or we're trying to hold plus or minus a thou or plus or minus a couple tenths, then I'm going to make it a contour so that I can identify just that operation and run it until I get the desired result. So yeah, make those decisions as you go and see, yeah, it's nice having it within the operation, but if it doesn't give me what I want, I'm going to uncheck that box and put in an operation that will. All right, let's give it one more. All right, so again, it's just going between the lines, and this is more like the traditional lace. And let's take a look, because I think it is also going to blow out my material. All right, notice the lines are going, so being able to read and identify those toolpaths, in the that kind of isometric rotated view, it's not as apparent. But when we go to the Alt-1 top, that's the center line of my tool. I just chunked out a big portion of that peel, so I need to go back and look at what I did. But these are something to experiment with. Push the buttons, get a feel for how they operate and what it can do for you. Again, as the machines, you get into 10,000, 12,000, 15,000 RPM spindles, we're going to be able to up those surface feed per minute rates, increase the feed rates, and not do any, say, significant damage, any increased wear in your ball screws. It's going to be able to compensate and manage. And then the other consideration is, does the machine have high-speed look-ahead? If you only have 40 lines of look-ahead and you are flying along at 100 inches a minute because you can, you're probably going to end up with a little dithering on one of those previous. Let's go ahead and hide this one out so we can use a better example. So each time, we're cruising along, we're making these cuts, and we're at an elevated feed rate. If the machine can't keep up with how much code it's consuming, it will dither. It will stop and it will wait, and that is only milliseconds, but you will hear it and you will see it in the finish. So if the machine's not capable of 120 lines of look ahead, then you're not really gaining a lot of advantage with the getting really aggressive with the high speed. There are lots of advantages with doing the high speed, even at the lower look ahead, because you're going to have less tool load. You're going to have that increased tool life and wear. But it's something you have to experiment with. I mean, the technology, the Vericut, and some of the other first trochoidal cuts have only been out for, I would say, less than 10 years in an industry that has traditionally been, you plunge in, you walk the tool around, you retract it out, and it doesn't do all this fancy stuff. The other thing to keep in mind too is this is going to generate a lot of code. We're going to see, a standard pocket may be 500 lines of code. This may be a couple thousand lines of code because it has all these little extra moves in it. Or if it picks it up as a true XY location, it may come through and every one of those points ends up with a line of code. So again, try it and see what you get for the results. All right, so I'm going to go ahead and hide that one. So let's say, as far as the assignment, this is an experiment. Try to put a couple of these high speed in, see what works for you, see which ones make the most sense for your your machining style. And they're basically a springboard. You start off slow and small and let it build up and do a little bit more for you. All right, so what did we have for our level? Let's go back to the DIMS. We were 1/4 inch on a 1 inch, so this is 1/2 inch. I don't think I'm going to get that 1/2 inch tool in there. And it's only 1/8 or 3/16, so 1/875 deep. And so I got to think about. I will say, for one of the things to watch out for is if you leave the DIMS on, I believe they are valid to chain to. So they are probably another level of, yeah, you don't want to do that. So if it's not something that you're using to create the geometry, we'll kind of stay away from it. All right, so the slot geometry is going to go around the outside. With a 1/2 inch tool, we're not going to be able to make that. And then with a 3/4, would probably like to do the 3/4 through with the 1/2 inch. So let's go ahead and build that one in. So I would think that would just be a regular contour. And the chain picks up on the arc, and that's going to put us into conventional. It was one of the things that I was looking at the start and end. We can transition. So if I was just doing the contour around here and I picked this, but I really wanted to start it over here, we could back up the start points, move them forward. Let's see if we can reverse it. That's going to put me in conventional. Because this is a contour, though, I'm still going to have to check that chain. So reverse. That's kind of handy to have on the chaining menu now. But I still want to look for that arrow to make sure that that arrow is pointing to the interior, that I'm on the left side. Visually, again, I will always go to this visual, because when I come down to, the cut parameters, and I looked at left compensation, I got to think about that. The arrow is going the right way. That gives me a much greater sense of confidence. All right, so we are staying with the contour. We'll stay with the tool. And cut parameters, computer. Let's go ahead and comp this on. And we're going to set it to ramp. And a 3-degree ramp angle. What else did we need? And if I do this right, there might be a little bit of a witness mark where this ramps in. If I don't get a lot of tool deflection or get too aggressive, I should be able to swing this bore all the way down. And again, it comes back to tolerances. If I have a nice ±5 tolerance and the surface finish is not super crazy, I'm going to be able to go through this without a lot of surface, noticeable surface wear in there. So the lead-ins, we're going to need to be pretty small. So I was 1/2 inch tool on a 3/4 inch. So these are going to come down to maybe, let's go 20 thousandths, since it's starting really close. And then I'll transfer it over. Breakthrough, we'll stay with the 10 thousandths. And then multiple passes, no, don't need to work in or out. So I guess that would be the alternative, is if we didn't do the dynamic, which is going to try and minimize the number of passes, we would end up doing a contour that would step in and remove the material. Since there's not a lot over here, we would start out here and then do multiple passes to come around the part. So that would be one for comparison. And then our length, top of stock, and the -0.5. I'll switch back over to the absolutes, and we'll go ahead and take a look. All right, so the one I did not check, but it looks like it's in there, is I will usually take at least 1 or 2 spring passes, so that any of that tool deflection, any of the taper that were generated by spiraling this in and loading and unloading that tool, it gets a chance to resolve it. So that would be under the cut parameters, one-way ramping for open. No. Okay, I have to go back and find it. Well, I know there was a button somewhere that said number of spring passes. So, well, since I'm not seeing it, we'll move on. Okay. So with the slot, then we'll need to go to next size down. Let's go with actually with we need to make that all. Now we can switch it to slot. It's probably up here where I was looking for it. So we'll send it all the way around. Change geometries to the interior. And on the slot mill, then I want to switch the tool so it has enough room to move around. So probably a 3/8. Pick that one back up, maybe at 10. All right, so we give it some variation. We'll stay with the wear. 180 degree arc entry and sweep. I don't know that it has to be that much. Yeah, we'll go ahead and leave it. Hopefully it has enough room to make that 180 degrees. We're not going to have that much on the walls. And there again, what kind of surface finish, what kind of tolerance are you trying to hold on this slot for it to be functional? 3-degree ramp, and we're only going 3/16, 187. So maybe I'll drop that down to half so it doesn't just embed itself. And step over amount can be the radius of the tool. There's a finish pass, so we'll let that one go to 2. And breakthrough amounts, no breakthrough. Linking parameters, we'll go up to the absolutes. And minus 0.1875. Let's see, what did it do? So it still thinks it's too big on one of the lead ends. Or I missed something. Plunge angle, spacing, finish passes as a likely culprit. Let's bring that back down. All right, so that one finish pass, and there's going to be things that jump out of you, things you'll remember from last time, things you're just going to have to push buttons and see if it gives a desired result. So that one finish pass kind of jumped out at me when I was looking at, 50 thousandths. There's not really 50 thousandths. We have 1/8 of an inch of clearance between the tool and the width of the slot. So that basically leaves 25 thousandths if we're 50 thousandths on the spacing or 50 thousandths off the wall. So that's kind of an obvious choice. And then the next one would be back up at the cut parameters, taking a look at the entries and the sweeps. Okay, so let's go ahead and we will show all of those. And I want to run the simulation because even if I missed that peel, I think it was the peel, or the blend operation. I'll get it right here. Even if I missed that blend operation, I should be able to see it in the simulation. All right, so if we just do the back plot, the back plot's going to be fairly quick and easy and be able to see results instantaneously and get a pretty good idea that it's not doing anything really strange, although those are some strange moves. What's that? Not really. Is if you can increase that feed rate by 20 or 30%, that extra move is nothing. Each of those extra moves is nothing if the tool is going to disengage and engage consistently in that part. So it's surprising that further into the parameters, I can increase that circle So even though it's not engaged, maybe I increase that from the 12 or 18 or whatever I said I was going to start with. I could make that up to 30 or 40, and it would speed up and slow back down, speed up and slow back down. There's a lot of juggling going on to what is the machine capable of, because I'm always going to preface it with until you observe and react, until it's at the machine and you see if there is any benefit to this. Probably the main thing is still back to that. If I had to take all of these passes with that open contour, I'm probably ending up with something very similar, but it's still not going to manage. It's going to try and come all the way around and then all the way around. This is going to take those little nibbles, and we're going to save enough time there that even these little circular kind of loops, and I could even go back in and start to fine tune those loops, make them a little bit smaller, cause them to be a little bit less pronounced, and get this dialed in. All right, so I didn't see it on the backplot preview, but if we go into the verify, this should be pretty apparent that I have an issue. All right, so a big portion of all of this is being able to read what's going on your screen and projecting it to what's going to happen on the machine at the machine. I have expectations. I've gone through this the setup, and let's slow it down just a little bit. All right, so there's the nibbles off the end that it's not having to take a full, and maybe even a full air pass to be able to clean those up. All right, and then having it come back around. And each of the programs that have a high-speed module, so SolidCam does theirs a little bit different. HSM does theirs a little bit different. Each one has its own little idiosyncrasies that go with it, but the idea is to reduce that tool load and get longer tool life while you're making those cuts. So I had the same reaction. The first Turquoise cuts, I saw, oh, that's a monumental waste of time. Why would I ever do that? And then you start making the cuts and you go, oh, that's why I would do that. Yes.
There's the tool dugout on the top
Yep.
right.
Yep. So that was the blend, and we were looking at that as going to the edges. If you don't catch it in the toolpath, looking at that operation, then the simulation should be very apparent that, oh no, that's going to be bad. All right, so you're using all these tools, and that puts you up into, 95% confidence. I go back and I make this correction. I run the simulation again. I take this out to the machine. Other than being concerned about my feeds and speeds and touch off and some of the work coordinates, that's just going to be habit. Until we dial in, I know that this half-inch tool, if I'm on a 10,000 RPM spindle machine, I'm running that half-inch tool at 9,000 RPM, 40 to 60 inches a minute. If I'm taking 50 thousandths at a nibble, I'm probably running it up at 70, 75 inches a minute. And it's going to go through and blast that material out with chips flying all over the place. But the more aggressive you get, that 1 second of machine time that you're going after, when something goes bad, and eventually something will go bad, it goes very bad. And it's not something you can prepare for, other than just accept that at some point that part's going to come out of the vise and the tool's going to probably come with it, and it's going to scare everybody. You just don't want it to scare you so bad or damage the machine or damage one of your people. So, maybe not in that order. People, machines, and then all right, we'll call that good.